In 9.4, we're going to look at three different types of variation that can occur. And those three types are actually direct, joint, and inverse variation. Some examples: the circumference varies directly with the radius. Okay? If there's direct variation, the circumference, the thing that varies directly, so circumference varies directly with the radius, is you're multiplying, to find the circumference, you take some constant, and we use a k here when we're defining these different types of variation, times the radius. And in this case, as you can see right here, that k has been replaced by 2 pi, which is a constant. 2 pi is approximately 6.28. Okay, so we say that if I actually took the circumference of every circle and divided by 2 pi, or I'm sorry, divided by the radius, it would actually equal 2 pi. Okay, so if I had an r, notice if I multiplied both sides by r, I'd have that. Okay, so if I took every circle, because as I get the circle, the circumference gets bigger, it varies directly. The radius is going to get bigger. Every time you divide that, it's 2 pi. Okay, so with direct variation, as x increases, y increases, or as x decreases, y decreases. What that means is the variables do the same thing. Okay, all direct variation functions are linear functions that go through the origin or go through a y-intercept of 0, and kind of the general form we use is y equals kx. Okay, so y is what we call the constant of proportionality. With direct variation, it's also known as the slope. Okay, so here's just defining y varies directly as x. So if y varies directly as x, another form of that would be these two have the same, or are the same equation, because if I multiplied both sides by x, we'd have y equals kx. Okay, I personally like this form better, and we can adjust to the other form. K is the constant of variation, constant of proportionality, the variation constant, different terms for it. So if we go here, now we have joint variation. All that means is you got one more variable. Instead of just y equals kx, now it's y equals kxz. Joint variation, when one quantity varies directly, as the product of two or more other variables. So in this case, I have the product, so I bring in another variable here, as that's the case. Now, the other form of that would be if I took y and divided by xz, it would equal my constant, or constant of proportionality, or variation constant, whatever. Okay, we don't use this form a whole lot. We stick to this form, and then we can algebraically adjust it as we need to. So that's another one that'll be on your reference sheet. That's joint variation. Okay. An example here for a set distance, rate varies inversely to, oh no, we're going to get into inverse variation. Okay. Inverse variation, as x decreases, y increase. Inverse means the variables do the opposite. With direct variation, they did the same thing, so that's proportional. With inverse variation, as one gets smaller, the other gets bigger, or vice versa. So all inverse variation are in the form xy equals k, and this is kind of the form I like to use. Now, if you rearrange that and solve that for y, if I had xy equals k, if I solve that for y, I would take my variation constant, divide by x. And none of this is going to make a whole lot of sense until we actually get into some examples here. We're just defining things. So y varies inversely. We're really looking at, and I use that one. I don't stick to the one that's got the fraction in it, even though it's really the same thing. I kind of use that general form. We don't really look at it as the fraction in that one. We want to use that general form with joint variation too. Okay. Some examples here. Think about this. Fuel. The more I drive, what happens to my, if you look at your two variables here, the more I drive, the more miles I drive, what happens to the fuel? Well, the more miles you drive, so as the miles you drive goes up, what happens to your fuel? It goes down. So that would be not direct variation, because they're not both doing the same thing. That would be inverse variation. The amount of miles driven is inverse variation to the amount of gas you're going to have left. Okay, if you're talking about the amount of gas remaining. Okay, obviously, as the more miles driven, the more amount of gas you use if you looked at it differently. But as you're talking about the gas gauge and what you have left, That would be inverse variation. Okay. Steps for solving variation problems. Write the general equation, the equation with only variables and k, substitute in the given information, solve for k, and then write the particular equation. So we're going to figure out k in step 1, well actually after we do 1 and 2. The general equation, so putting the x and y or x, y, and z if it's joint variation back in, value of k, plugged in, and then substitute the rest of the information to answer the question or find what they're asking you to find. So it's pretty straightforward here. Y varies directly to x and y. So we want to use the general form of direct variation. So y varies directly to x. Actually, I highlighted too much there. I'm looking at this part right here. So y is equal to k times x. There's my general form for direct variation. Now what you want to do is you want to take the given information when I know these two variables, and you want to plug that in over here. So I want to put negative 15 in for y, because that's what y is equal to, and then k is what I'm going to find after this step, times 5. Now, how do I find k here? Well, I divide by 5 if I was going to solve this for k. So k would equal negative 3. So there is kind of steps 1 and 2. Now, you go back up here, we're going to rewrite our general form, y equals kx, but we're actually going to rewrite that as y equals, I now know k is negative 3. So there's my direct variation equation now once I found my variation constant or constant of proportionality. Now what you want to do is you want to take this. We're trying to find y when x is 3. So I'm going to take and I'm going to substitute that in. I want to find y, so that's still going to be a y. And now I want to put 3 in for x. So what does y equal? Negative 9 when x is 3. So it's kind of, even though I listed 4 steps, it's kind of solve for k in the first one, write your equation that puts the k in with the variables back in, y and x, and then find the variable they're asking you to find. Not too difficult. Here's another example. Direct variation, so y equals kx. Okay? This is the given information where I know both variables, so that's going to go in here first. 12 goes in for y. K times negative 3. I'm going to solve this for k. So I'm going to divide by negative 3. So negative 4 is equal to k. Now I take that and I go back up to y equals kx, my general form for direct variation. I put negative 4 in. So there's my direct variation equation specific to this problem. And now I need to find y when x is 7. So I'm trying to find y when x is 7. So I'm going to put a 7 right there. So what does y equal? Negative 28. Now, with direct variation, there is another way you can do it. You could do this. I could say when y is 12, and this only is proportional on direct variation. Okay, so y over x is what I'm going to put. So y is 12, x is negative 3. What's y when x is 7? And notice if I cross multiply here, okay, I take negative 3 times y equals 12 times 7. I would divide by negative 3. You are going to get, if you actually calculated this out with a calculator, negative 28. With direct variation, you could set up a proportion. Okay, that's not going to work because the other ones aren't direct proportions. Just another way to do it. If you took 12 times 7 divided by negative 3, it would be negative 28. All right, so joint variation, varying jointly. So here's what we want to do. We want to write down joint variation, which is y equals kxz. Now, notice this is where they're telling me to find y. So we're going to use this information second. We want to actually start with this where I know all of these. That's going to be used first, because it's not where they're asking me to find one of the variables. So we're going to use that first. We're going to put 12 in for y. Okay, we're going to find k from this. X is 3, z is 8. So I really have 12 equals. I'm going to go ahead and multiply these two. So it's k times 24. solve for k, so I'm going to divide by 24. So k is a half, or I'm going to go ahead and use the decimal. It's 0.5. So now we're going to take what k is equal to. We're going to come up here, y equals kxz. So I really know it's y equals 0.5 xz now, so I'm going to put 0.5 in there, or a half. Now I take what I'm going to use second. That's this stuff right here. I'm trying to find y when x is 10, so I'm going to have 10 in here for x. Z is 5, so I'm going to have 5 in there for z. So I'm really taking 0.5 times 10 times 5. 10 times 5 is 50, times a half is 25. So y is 25. I got another example just like that. Y equals kxz, because it is joint variation. Again, here's where they're asking me with this group of numbers to find y, so that's the missing one. I don't want to use that first. I want to use this first. So we're going to come and plug that in. Y is 11. We're going to find k in this step, times 5, and z is 22. So if I actually multiply those, I get 110, so it's k times 110. If I divide both sides by 110, k is 1/10, or 0.1. You can use the decimal if you want. So now what we're going to do is we're going to take that up here. We go into our general form. Y equals kxz, so we now know it's y equals 0.1 xz. And now I want to use this information. I'm trying to find y when x is 3 and z is 2. So it's 0.1 times x, which is 3, times z, which is 2. So 0.1 times 3 times 2, which is 0.6, or 6/10, which if you wanted to list it as a fraction would be 3/5. So either 3/5 or 0.6 in decimal form. And the last thing we're going to look at is inverse variation. Inverse variation, the general form is x times y is equal to k for inverse variation. Okay, now notice we're not using x and y here. So they changed variables, so instead of x and y, we're dealing with a and b here. So it's actually ab equals k. So I'm going to kind of change my general form, just use the variables that they're asking us to use. Now, here's where I know both those variables. Here is where I'm trying to find a in this case, or one of them. So I want to use this first. So I'm going to say -6 times 2 is equal to k. Because a is -6, b is 2. Well, so k is -12. Now I want to come up here and I want to say, I'm not going to use x, y, I'm going to say ab is equal to k. That's the general form. Well, we know that a times b has to equal -12. And they want me to find a, right here is the one I'm trying to find, when b is -7. So I'm putting -7 right in there. To solve for a here, I would divide by -7. So a is positive 12/7, okay, or 1 5/7 if you wanted to give it as a mixed number. I would just leave that one as a fraction. I mean, you could find the approximate decimal. You don't really want to do any rounding here, so that one I would basically leave as a fraction. And one more, inverse variation. Again, it's a and b, so normally it's xy equals k, but we want ab is equal to k. And it's inverse variation, so that's why we're using that. We know these two, so we have 2 times 8 is equal to k. Okay, putting 2 in for a and 8 in for b, so k is 16. So we know that a times b has to equal, because it's ab equals k, we now know k is 16. So now I'm going to try and find a, so a is the one I'm trying to find. I'm going to put 6 in for b right here. So a times 6 is 16. We're going to divide by 6 to solve for a, because that's what we're trying to find. Again, it comes out to be a fraction. I'm going to leave it as 8/3, or 2 2/3. And again, this is a decimal that repeats. It'd be 2.6 repeating, so I would leave it as a fraction. And that is pretty much lesson 9.4.